Hey guys, today we are going to be continuing in graphing, still doing just some position time graphs and velocity time graphs. But today we're going to specifically be looking at how to translate between the two and kind of interpret what's going on with them. So we're going to start here by looking at the top graph. It's already drawn in. This one is pretty obviously position versus time. You know that it's position versus time because it says position over here. X is the variable, meters is the unit. And if you want to follow along on these notes, they are attached in Google Classroom. I forget to mention that normally, but they are attached in Google Classroom on your latest assignment. So you can go look at that and follow along with those if you would like to. All right, so we're going to start by looking at this top graph here. This top graph is position versus time, and it plots a course through a position. And we're just going to talk through, or I'm just going to talk through what's going on here. So right at the beginning of this graph, when time equals 0, if time equals 0, we're starting right here on the axis where time is 0. So down here, where time is 0, it shows that we have a position of -6, x equals -6. And all that means is that our object starts at whatever point is designated as -6. So I'm going to draw this as a number line down on the bottom. Again, in the classroom, I usually walk around. Oh, I don't do it on the bottom. Usually in the classroom, I walk around, but here I can't really do that. So we're going to draw a number line, go up here at the top. In the middle, we'll have 0, and I think this counts in 2s, so we'll go by 2s. Up here, all right, so our graph here starts at -6, which means if I follow this motion on the number line, then I'm going to start at -6. So I start over here at -6. Now, as I move up the graph, as time moves forward, I start moving from -6 all the way towards 8 at a pretty steady pace. So after 1 second, I'm going to have reached -2. And then after another second, I'm going to have reached +2. And then after another second and a half, I'll get all the way to 8. So to recap, I moved from -6 to 8, and I went from going from a negative to a positive, was moving towards the right, so I went in the positive direction. If I was going down to the left, that would be a negative direction, but instead I was going to the right. And the fact that it's a straight line means that I was going at the same rate the whole time. I was moving the same amount each second to get all the way from -6 to 8. Now, we said yesterday that slope equals velocity. If you didn't watch the video yesterday, go watch that, and it'll explain all about why that is. But slope is the same as velocity for position time graphs. So if we want to know how fast I was moving from this graph, we could just use the slope. Now, there are 4 different sections of graph here, split at these points. So there are going to be 4 different slopes that we calculate. If we look at this first section, we'll call it section A. We'll do section A over here. All we need to do to find the velocity is find the slope. Now we know slope equals rise over run. Know that from math. Today we are actually calculating that. If we look at part A, we need to know how much it rises. It starts at -6, and it goes all the way to 8. That amount of rise is 8 minus -6, which is 14. And we divide that by the run. The run is 1, 2, 3, 4, 5, 6, 7. But each of those things is a half, so it's really 3.5. 14 divided by 3.5. And you can use some number sense or type that into a calculator to get an answer of 4. 14 divided by 3.5 is 4. So for that section right there, section A, my velocity, because velocity is equal to slope, is equal to 4 meters per second. And it's a positive 4 meters per second because that's a positive slope. It's going up and to the right. So my velocity for part A is 4 meters per second. You could similarly calculate the slopes for all of these other sections, B, C, and D. So go ahead, pause the video, try to calculate those 3 slopes on your own using rise over run, and I'm going to write them down over here on the side. So whenever you are finished with that, you can unpause the video and check your answers. Go ahead and pause that video now. All right, so for those, you should get part B has a velocity of 0.4 meters per second. Part C has a velocity of 0 meters per second because it's flat. And part D has a velocity of negative 1.5 meters per second. That negative is important. That negative means we're going back to the left. So really what this graph would be representing motion-wise, I'm going to do it on the number line up here, would be starting at -6, going towards 8, slowing way down to get up to 9, chilling there for a little bit, and then going back kind of slowly to 0. Okay, so the fastest section was section A because it's got the steepest slope. Section D is in the middle amount of speed. Section B is really flat, so it's really slow, and C is completely stopped. Okay. So we've pretty well analyzed that position time graph. Now let's look at how to translate that into a velocity time graph. And we now have lots of really good information here. We know all of these things. We know the velocity at A, the velocity at B, the velocity at C, and the velocity at D. Now I'm going to scoot my paper down a little bit here. I might have to zoom out a little bit. Yep. There we go. So for part A, my velocity is 4 meters per second. And all I need to do is graph that on the velocity time graph. 4 meters per second is just 4 here on the graph because this is a velocity time graph. So for all of part A, I was going 4 meters per second. The slope for that line is 4 meters per second everywhere during part A. And part A lasted for 3.5 seconds. So for 3.5 seconds, the first 3.5 on this graph, I was going 4 meters per second. I'm going to make that velocity be 4 meters per second, right there. For part A, that's how fast I was going. Then for part B, I got super, super slow. I went all the way down to 0.4, but still on the positive side. I'm going to erase that little dot there. And part B lasted all the way up until 6 seconds. So I'm going to start off at 3.5 seconds going 0.4 meters per second all the way up until 6 seconds. Right there. Perfect. So we went those 2.5 seconds at 0.4 meters per second. When we get to C, which is 6 seconds, we stop and we go 0. So I'm going to put a little dot there and go 0 all the way till the end of section C, which is 8 seconds. And then lastly, we have section D, where we're going negative 1.5 meters per second. And section D lasts from 8 seconds to 14 seconds. So we're going to go down here to negative 1.5, go from 8 to 14. And now we've taken a position time graph and translated it into a velocity time graph. And it does look a little bit weird on the velocity side. It's just some different levels. It's not like a connected graph. It does look a little bit different, but that's okay. All you had to do was look at your position time graph, find the slope of each section, and then graph that slope's numerical value on your velocity time graph. Okay, so you do have a worksheet to do over this. Please let me know if you have any questions, need any help. Look forward to seeing you in class.